In the previous video, we designed the first prototype of the FrameDeck in Fusion 360. We 3D printed it and did a preliminary test fit and noted the changes that would be needed for the final revision. We tested out all the wiring and made sure that the display and digitizer also worked. In this video, we're going to finalize the 3D model, print it out, write up the code for our Arduino-based controller, and wire everything up. Let's get started. So here we have the final model. Some of the more major changes from last time are the USB-C port on the exterior of the device. We've got two now, one on top and one on the bottom. You'll notice their placement is not centered, and that's simply because of the type of Thunderbolt extension cable I'm making use of. Since they don't have a right-angled connector, they would interfere with the battery and mainboard inside the chassis if I were to place them in the center. So the next best place is to put them off to the side. Another major change is how the Thunderbolt cables themselves are connected to the chassis. They have these tiny brackets that slot into the walls and then are screwed in from the outside. In this model, you can see I've countersunk the holes so that the M3 screws would sit flush. Another change is that the device now has a power button. Since the framework mainboard has a built-in power button, I figured making use of it instead of trying to solder on an additional button would make more sense. After all, the goal is for it to be a drop-in replacement for any framework mainboard, so modifying the board in any way kind of defeats the purpose. Instead, I've adopted a similar mechanism to the framework cooler master case. I may switch it out for a non-swivel design, like the trigger and shoulder buttons, but time will tell if it works or not. I've also slightly changed the dimensions of the holes for the screws, or more so the threaded inserts. Since my final objective is to have this either be printed in resin or in PLA, heat-threaded inserts won't work with resin, so I've come up with, hopefully, the perfect middle ground where I can still heat up the inserts for PLA use, but then press fit in the insert for resin use. That's about it for all the major changes to the chassis. So let's move on to the next part. So for the controller, we're going to be using an Arduino Pro Micro. Any small Arduino with an ATmega32U4 CPU will work, but I recommend using the same Arduino I use for it to properly fit inside the chassis. All the links to each component can be found on my GitHub, and all parts can be purchased online from AliExpress for cheap. For this controller, we're going to make use of the Arduino joystick library. With this code, we can initialize all our inputs, digital and analog alike, and set them up to our respective inputs in our OS. I know this isn't optimal since we'll have to use a third-party application to map all our inputs in Windows like X360CE or map our controller within SteamOS. So if you guys have a more elegant solution, please let me know. Now here I have the code running on another Arduino on this breadboard, and all the inputs look good. So let's move on to the next section. So here's a time lapse of the chassis assembly process. Since my print bed is too small to print every piece in its entirety, I started off by gluing the pieces together with Dollar Store Crazy Glue. The digitizer here is press fit into the assembly, so I used it as a guide to line up my two halves. I then, out of screen, added the heated inserts. I don't think this will work very well for resin prints. These inserts can be press fit, but I don't think they'll hold on for long, so glue here would be advised for those using resin. The screen then goes in next, and the corner pieces are screwed in to align the screen and the digitizer correctly. The screen controller board is then placed on top of a thin silicone sheet for heat insulation. At which point, the brackets to hold in the entire assembly are screwed in. This next section is for the trigger and shoulder buttons assembly. I'm reusing the same assembly from the previous video, hence why it's white. Each assembly is press fit into place and works very well. Wiring the potentiometer and button will not be fun though. I then add the mechanical switches PCB and screw those in, as well as the joystick assembly. You'll notice that there are quite a few pads on the mechanical switch PCB, but most aren't used since my initial plan was to make it pass through the signal from the joystick, but I dropped that idea in favor of having the same PCBs on both sides of the unit. I then add the start and select switch with its retaining bracket. Here I now attempt to complete the wiring for the digitizer and screen controller board. I have this custom USB-C to micro USB data cable plus USB-C power cable to provide power to the screen's controller board via USB-C, but also provide data to the digitizer's micro USB. The USB-C display adapter goes in next, at which point the battery and main board can be screwed into place. So let's just fast forward to the grand reveal. So here is the final product. It took so long to design and create this project, and it doesn't look half bad either. It's got some weight to it. At 2.1 pounds or 952 grams, it sure is a hefty boy. The Steam Deck weighs in at 1.48 pounds or 669 grams, nice. And the Asus Ally, which this device chassis is inspired from, is 1.34 pounds or 608 grams. That's nearly 1.6 times heavier, and it's noticeable too. This is most likely due to the full-size framework battery, as well as the plastic itself not being optimized for weight, but more for structural integrity. I have pretty small hands, so the triggers require some finagling to get my hands in the right position, but once I find that sweet spot, it's not bad. People with large hands will definitely appreciate this more. I'm glad the Arduino controller works. Everything shows up well in Windows. I'll have all the wiring diagrams on my GitHub where you can find all the 3D models as well as the Arduino code. One important note is I could only fit one speaker assembly on the right side, so no stereo here. Both Thunderbolt 3 ports work well, and the mechanical hot swappable switches are awesome. I couldn't be happier with those. However, I think it's time we focus on what isn't great. The screen's heat, or well, the screen's controller board. It just gets way too hot. The silicone helped isolate it some, but it still gets warm. Not uncomfortable to the touch, but it's getting there. Fortunately, the heat doesn't appear to be transferring to the battery, but it's still not ideal. A solution would be to provide some sort of ventilation and active cooling, perhaps by using a 10mm fan. The screen overall, it's a great screen, but it's taking up an entire Thunderbolt 3 port. Technically 1.5 ports if you consider the digitizer. A solution to this would be to have a 7-inch 40-pin EDP display, so that it would plug right into the framework's EDP connector. But as far as I'm aware, they don't make them. I alluded to this before, but boy, is this thing heavy. It sits nicely in your hands, so it doesn't feel that heavy, but you can tell it's no thin and light, that's for sure. Joysticks. They protrude a little too much, so they feel high up, and I only just noticed that I forgot to print out the joystick covers. Oh well. A solution would be to use more Switch-like joysticks, or find joysticks that simply have less seat height. So I guess it's time to make the final verdict. Should you build one? No. Well, not yet. It's still very much a prototype. There are so many things to be tweaked, upgraded, or completely redesigned. In retrospect, if I made the device even 5% wider, it would have made assembly so much easier. If I used ribbon connectors on the custom PCBs to connect to the Arduino, it would have made wiring far less messy and more enjoyable. Truth is, if you just want to order the parts off of JLC PCB, which I checked would cost less than $8 Canadian, shipped by the way, and expect everything to work flawlessly, you'll be disappointed. But if you're a tinker, 3D modeler, 3D printer enjoyer, or anyone who wants to try and ameliorate this project or add your own flair to it, then this is for you. I've added all my work and files on my GitHub, and invite anyone to either work off of or simply take inspiration if you deem this revision to be completely doomed. Also, if Framework is watching and you want to hire your boy for an official FrameDeck unit, my DMs are open. On a serious note, thank you all for the support, and I hope to see your guys' FrameDecks in the future.